Today we are going to look at this question paper here. This one is for both. It's suitable for both grades, right? It's suitable for both grades, grade 10 and 12, right? Grade 10, 11 and 12. I mean, okay. So this one, question 5, they are saying what they are saying. Sketch below shows the graph of f of x is equals to x squared plus minus 2x minus 3, and g of x is equals to 3 minus x. A and b are the x-intercept of f. The graph of f and g intersect at C and B. Okay, C and B are the intersection of the two graphs, and then they are saying D is the turning point of the graph of f. D is the turning point of the graph of f. And then now the first question, they ask us to determine the coordinates of C. C is the y-intercept of both the graphs. Remember, the C is the constant, right? The number which is a constant is always our C, right? So our C for the graph of g of x is -3. Also, if we look at the f of x, obviously we're going to see that our y-intercept is at -3, right? We'll notice that our y-intercept is at -3. Okay, so let me just put this one here. Yes. So it means that my coordinate of what? My coordinate of C is going to be what? It's 5.1.3, 5.1.1, right? So the coordinates of C are going to be 0 is to -3, right? So those are our coordinates of C. So let's quickly go to number 2. Number 2, they want us to determine the length of AB. So for us to determine the length of AB, we need the coordinates of A and B, right? And then how are we going to find the coordinates of A and B? The coordinates of A and B are both the x-intercept of f. It was mentioned here, right? Are both the x-intercept of f. So on the x-intercept, I know that my y is 0, right? So 5.1.2, I'm going to find what? I'm going to find f of x is equals to x squared minus 2x minus 3, right? And then after that, then I can equate my y with 0. So it's going to be 0 is equals to x squared minus 2x minus 3. So after that, I can easily factorize my thing. So it's x minus 3, and then x plus 1, and then all equals to 0, right? And then my x will be 3, or my x will be -1. So those are the values of x, right? Or x is 3 or x is -1. So remember, with the horizontal distance, there is no need for us to use the distance formula. We know that the bigger x minus the smaller x, right? The bigger x minus the smaller x, so the bigger x is 3 and the smaller x is 1, right? So our AB is just gonna be what? It's just gonna be 3 minus -1, so which is going to be 4 units, right? So our AB is going to be 4 units, right? Just like that, right? Then we accumulated our 4 marks, right? And then now they are saying calculate the average or determine the coordinates of D. Okay, the coordinates of D is our what? D is our turning point, right? And then we know the equation for the turning point of 5.1.3. So for the turning point, we know the axis of symmetry. The equation for the axis of symmetry, x is equals to -b over 2a, right? X is equals to -b over 2a. And then after that, what is our b? Our b is going to be what? Our b is -2, right? So it's going to be negative into -2 over 2, and then our a is what? Our a is 1, right? So the answer there is just gonna be +1, right? The answer is just gonna be +1. So the axis of symmetry is at -1, right? So it's at +1. So this is our axis of symmetry, right? So to find the y value, obviously we're going to substitute this x of the axis of symmetry to the main equation, right? So we're going to find f of 1, right? So f of 1 is going to be 1 squared minus 2 into 1, and then minus 3. So the answer is going to be, there is -5, so it's going to be -4. Does it make sense? Yes, it does. -4. So the equation of the coordinate of the turning point, which is D, it's just gonna be what? It's just gonna be negative what? It's just gonna be 1 is to -4. 1 is to negative 4. So that is our coordinates of D, right? So now let's quickly go to the next question. The next question, they say what? They say calculate the average gradient between point C and D. Between point C and D. So the average gradient, we know that's going to be top y minus bottom y, right? And then to calculate that one, okay, because it's on the graph of f of x, right? Okay, this one is building up to something, right? We don't usually ask you about the gradient, so they ask you about the average gradient on the curve. So this will lead to something more, especially when we are in grade 12, when we're doing calculus. This is calculus, right? But in this case, it's just a normal question, which is going to be what? It's 5.1.4, 5.1.4, which is the normal thing, which is m is equals to y2 minus y1 over x2 minus x1, right? So what is our y2? So remember the coordinate, the other coordinate is what? Is 0 is to negative 3, and then this one is 1 is to negative 4, right? So it's going to be negative 4 minus negative 3, and then all over is it 0 is we started with 4, so it's going to be 1 minus 0, right? So the answer is going to be negative 1, right? Because I've got negative 1 on top and positive 1 on the bottom, so the answer is going to be negative 1, right? So that is our average gradient. So let's look at 5.1.5. So with 5.1.5, they want us to calculate the size of OCB. Where is OCB? OCB. So they want us to calculate this angle here. Sorry for that. So they want us to calculate this angle there, right? They want us to calculate this angle here, right? So to calculate this angle there, how many marks did they give us? They give us 2 marks, right? So we know that, okay, it's a special angle, right? It's a special angle once I've got a gradient of 1 here, and then it means that here the coordinates, I know that is 3, right? I know that the coordinates at B is 3, right? I know that the coordinates at B is 3, and here is 3, and here is 0, right? So which kind of triangle is this one? So you know that here is 3, and here is 3, and here is 90, right? And there at the O is 90, sorry for that. And then here at O is 90, right? At O is 90. So you see the 3, that is an isosceles triangle, which is also have got 90 degrees, which also automatically gives us that here is 45 degrees, and here is 45 degrees, right? So even if you just write the answer only, you should be able to get the full marks, right? So OCB is just gonna be 45 degrees, right? It's just gonna be 45 degrees. There was no need for us to even go for what do we call that one? Inclination angle, right? There was no need for us to even go for inclination angle. And then now let's go to the next question, the last one, where they say determine the values of k for which f of x equals to k will have 2 equal positive roots. Okay, so that's a bit tricky, right? Because if they just talk about nature of roots, then we're gonna be doing this one. We're gonna talk about what? We're gonna talk about nature of roots, right? The equation for nature of roots, which is discriminant, right? So this one, in this case, in function, when you've got the equation like this one here, when you've got the equation like this one here, what you do is that you come on the graph there and you take that one. What is this k? F of x is equals to k. K is a constant. So the equation that equals to a constant, like if you've got the equation y is equals to 3, what is this? This is a horizontal line, right? So it means that this one is a horizontal line. You're just going to take k as the horizontal line, right? And then you test it on the graph. Where do I have a positive 2 gradient? Where do I have this kind of the roots that I want? So if k is somewhere here, you can see that, okay, the graph will never touch k, so there is no roots, right? And then if k is somewhere here, then you can see that the graph touches k 2 times, right? So it means that we've got 2 roots, but unfortunately we've got the other which is negative and the other which is positive there, right? And then if k is somewhere here, you can see that we've got how many roots? We've got 1 root. Remember, here is when k is equals to what? The turning point, which is negative 4, right? And then here is when k is less than negative 4, right? And then here is when k is greater than -4, because the critical value in this one for nature of roots is just going to be that one, right? For just nature of roots, it's just going to be the turning point, right? So everything starts at the turning point, right? From the turning point upward, we've got 2 roots. From the turning point downwards, we've got no roots. And then now let's look at another point what they mentioned. They say we'll have 2 unequal positive roots. So you can see that here we've got an unequal, but the other is negative, the other is positive, right? So let's look at where we can have both positive. You see here, they will be both positive and unequal, right? So you can see that, okay, that point they have got a positive and unequal. But let's look at when our k passes at c. When k is equals to -3, you can see we've got the 0 and then we've got a positive. But the question wants us to have 2 unequal positive roots, right? So for 2 unequal positive roots, it means that it's between what? It's between this turning point here and this point here, right? So it's between -3 and 4, right? It's when k is between -3 and 4. So because it's between, there's an intersection. So 5.1.6, the answer is going to be -4, k, and then -3, right? So the question will be like, the answer will be like this. And then they say what? Have 2 unequal positive roots. So 0 is not included, and then equal roots are not included also. So the answer is just like that, right? So there is our answer. So the answer, I'm sure marking allocations will be like this, right? I'm sure the marking allocations will be like for critical values, 1 mark for critical values, understanding that is 3 and 4, right? -3 and 4. So 1 mark is for this inequality, and the other is for that inequality, right? So you can see that our marks gonna be, and then this one fits 2 marks as it is, right? This one fits 2 marks as it is. And then 5.1, the other one is 5.1.4. 5.1.4, they say they wanted the average gradient. So average gradient